My name is Anton Karneliuk. I'm a network manager in TAG hosting and a technical fellow at Karneliuk.com. And what I will guide you through some ideas of what we were obtained when we was working with gNMI with the Python, and how we landed creating our own model, which is called pyGNMI, which is intended to help you with managing your networking devices with Python and gNMI. We'll briefly touch 3 points. We don't have that many time. First of all, how the network programmability landscape looks today and where the gNMI is in this landscape. Then we'll take a look on what is gNMI itself and why it is so popular or getting popular. And finally, what is exactly pyGNMI, why we decided to create this, and how you could benefit from using it. First of all, about the automation. If we take a look at very, very high level what automation or how automation could be implemented, we could roughly split it in 2 big buckets. The first one is text-driven automation. Second is a model-driven automation. Text-driven automation is probably something that vast majority of you have done at least once in your life. It's where we create the configuration files. Whatever it is, it might be applied to the Linux, could be applied to the traditional network device, which is not having the latest software releases and therefore cannot benefit from any model-driven interfaces. And we push this configuration, creating the file. In case of Linux, we might need to restart some daemons, and we'll give this, and we get this configuration applied and up and running. There are 2 approaches why we can do this. First, if, as said, we don't support model-driven things on the devices. Second, if you would like to have a configuration which is 100% in line with your documentation system, where there are no manual changes applied at all, and therefore no discrepancy to the standards from your security perspective, and so on and so forth. Second approach is a model-driven thing. This is a YAN clan. So YAN is programming language, but in the vast, more commonly used sense, this is a set of the data models, which is explaining how internally the data, in terms of configurational data and operational data counters and so on, is structured inside the network element, so that you could either use it for the configuration or to obtain the operational information, what is happening in the network, in the same structure of key value pairs. So it's create a hierarchy inside your device. The YAN as a tool could be used with any other protocol, such as netconf or restconf or gNMI, what we'll be talking about. In general, it gives you a look and feel how to manage a network devices like any other application. So not looking into specific interface, you just send certain key value pairs, you are getting their response in the key value pairs format, whatever the encapsulation is. And then you could directly process this data, and that's why the model-driven approach is quite useful for being any sort of automation. As I said, YAN as a data model general language, it's protocol independent. It can be encapsulated in any data encoding that exists in the market. So XML, probably one of the most popular in the previous, the most probably old, but still quite widely used data encoding format, which is used in the netconf. Second is JSON, at the current moment, I think the most popular data encoding format, which is quite actively used with REST API. So for most people, their JSON equals REST API. However, they are a bit different things. And therefore, when RESTconf came to the network programmability world, the JSON were used as the encoding there. Finally, gNMI was popping up later. It has its own ecosystem of what should be used, and as encoding, they are using their protocol buffers, which where again the YAN could be encoded in the protocol buffers in specific format, and then push through the gNMI to the network element, so that you can collect information or make the configurational changes. gNMI historically come later to the path. However, if you take a look in the current especially data center world, and also a service provider, some vendors are putting quite a big stakes, even implementing gNMI in favor of any other RESTconf was never popular. netconf was and still quite popular, but some vendors even start putting gNMI before the netconf, like they think that will be managing all aspects of the device in the programmable way. So we could think why. So before we start answering the question why gNMI is getting so popular and why the vendors start looking into using the gNMI as like main mechanism to manage the network device in the automated way, we need to understand what is the difference between the gRPC and gNMI. So gRPC is a unified framework. It defines what types of the communication you might have between your client, which is the host where you do the management, and the server. In this case, this is a network element. So there are four major operations type defined. Standard thing like such as unary operation, where the host or server is doing one request and is getting the response back, or various types of streaming, where the client is doing the request and the server starts streaming and they respond, other way around, where the server is asking client to stream the data, or even the most complicated bidirectional streaming, where the client and server exchange information in the asynchronous way. So gRPC itself defines what are the mechanism, how to handle this transport, it handles the authentication, various types of the communication channel, which could be encrypted and non-encrypted, and so on. So that's defined the transport. So gNMI is a specification. So it is a specific set of the messages which tells how we should pack the information, in which format, in which sequence. It defines what exactly operations we will be using. So like a spoiler, we are using three operations, which are just unary request response, and one involving streaming, which is used for streaming telemetry. And that is why the gNMI is working on top of gRPC, if you could say in this way. So you might have gRPC and gNMI on top, but you have gRPC without the gNMI for other services. gRPC started its conquer in the network automation world from the telemetry like client, because it had a set in its set of the messages, a set of the communications, the possibility to stream the data. And we have the SNMP counters, we have the syslogs, but the telemetry, as Paul was talking in the morning, is quite a wow thing. There are a lot of things you would be willing to collect from the network information. There are various means existing for that. So gRPC gave opportunity to start collecting any data starting from counters and then looking more complicated data such as routing tables, LSDB, BGP RIPs, and so on. Once this protocol was already implemented, the vendors start looking, because anyway, vendors put in the effort, try to develop the software. And they start looking, we have this protocol, what else we could do with that? Looking further, okay, we have now gRPC for the telemetry, and we have the netconf, if we speak about the programmable way to manage network elements. Let's take a look whether we could use the same transport, so gRPC, to manage the devices as well. That is how the gNMI has come, which stands for the gRPC Network Management Interface. This is the set of the method which allows us to change configuration of the network element, such as create new, remove existing, or modify existing, collect the operational configurational data, and obviously implement the streaming under the same hood. There were further steps done to provide other aspects of the operation, such as rebooting the device or performing the software upgrade, so that everything could be done under the same umbrella using the same transport. If you are familiar with any network automation protocols or tools such as netconf, RESTconf, you could easily compare gNMI to others. So the very first task which we typically do when we start working with a network device in the programmable way, we need to understand what it can, right? So we need to get the information about supported YAN models, about supported, probably, if you speak about the netconf data stores, which is running, startup, candidate. In case of gNMI, we also would like to understand what are the supported encodings, because gNMI being built on the protobuf allows you to convey the data in others formats, such as bytes or JSON or ASCII text. And such a call is called capabilities. In the netconf, this is a get schema or just hello original one. in the REST-conf to just get to specific endpoints. So the second operation, what is typically we are doing quite often, we are collecting the information from the network element. It could be either configuration or the operational data such as live counters and so on, but in request response mode. gNMI is using get for that. Within the same get operation, it allows you to distinguish what exactly data you would like to collect, only configuration, only operation altogether. In the netconf, this is similar to the requests get or get config, depending, again, what you're connecting, config or operational data. In the RESTconf, clear there's just a get to our appropriate resource path where you are getting the information from. The configuration change in the gNMI, it's implemented with a single call or RPC set. It have certain keys internally, which allows you either to create new configuration or to modify existing one. Then it gives you possibility also to replace the existing configuration with a new one that you are going to provide. And the last but not least is delete if you'd like to get rid of some configuration which is not necessary anymore. In the netconf, that is handled by the edit config with various separation, where you could either create new configuration and merge with the existing, or whether you would like to replace. So some further metadata is needed in the netconf to do the separation, or separate code delete config, where you basically just cut off the certain branch from your tree of the network configuration. RESTconf has a variety of the calls to implement it: post, put, page, delete. So you need to know what are the difference between, so that you're not using put instead of patch or vice versa way it may. And obviously the power of the gNMI, where it started its path, the telemetry, the streaming telemetry, where the client could subscribe to a specific data passes, and the device, the network device where you subscribe, it starts streaming the telemetry on a predefined interval with the predefined encoding format, depending on what the network element supports. In the netconf, when I was looking through the standard, there is something which is like create subscription and notification. Basically, there was a mean created in the netconf to implement the subscription. However, I haven't seen that it's widely implemented. So some vendors had this implementation, but even across that particular vendor who has that implementation, there were not that many operating system covered. So then, understanding whether the gNMI, why it is getting popular, because in essence, even at this stage, assuming it is implemented to the latest specification, you can do all of management tasks with the device: collect information, change configuration in any shape or form, and implement the streaming telemetry so that you can stream data to your favorite visualization. I mean, Influx, Grafana, Prometheus, whatever. So what do we expect when we work with any Python library? So we are running the network automation trainings for quite a while for the customers. And when we are talking to our students, they're always suffering that the network engineer have to understand what is XML, how to decode the XML messages where they work with the netconf, because a lot of popular libraries which is existing for quite a while, such as NC Client, it's absolutely fantastic library, but you had to decode the messages yourself. So it doesn't give you possibility just in easy format to get the results. So when we was working with these things and with our students, we understand that probably what the network engineers like, just simplicity. So it should be easy to work with a library. So you don't need to care about meta classes and so on. You just want to give the data and receive it back. So the second is a performance. When you speak about the management of the network elements, and especially when we speak about like hundreds or potentially thousands of the devices that you need to manage, you need to understand that each and every second delay by one device and then multiplied by 1,000 devices, giving you quite a huge thing. So we were thinking that the interaction with the network elements should be as quick as possible. We start looking what's existing on the market right now. The OpenConfig, the initiative under which umbrella gNMI has raised, has its own set of the Python bindings, basically the Python models which you could import in your code. They have internal structure of all the messages, all the passes, all the possible calls. The problem with this, it is very complicated. Even if you understand Python quite well, you still will have quite a lot of questions. How would I construct the pass to get certain resources? How I would build the messages, how I nest one message into another and another in the short RPC. That's how the gNMI specification is created. So it's very good to use it directly if you have very good understanding, but for vast majority of the network engineers, it's overkill. So the second tool, which is existing, again, quite popular, created by, as far as I know, some Nokia folks, called the gNMI-C. Again, it has quite a rich possibility in terms of what can be implemented, all possible calls, including, say, a subscription. The drawback for us was that it's not a Python, so it is created in Go. It's good programming language. However, despite the people are saying go for Go, I don't believe that Python is there, and I think it will be there for quite a while. Second point here, it's not a Python model that we could use. So it's not a library, it's a CLI tool, and that's why it has not big advantage if you would like to create a certain code that in the Python tool we manage the network element. So what is the pyGNMI in essence? This is a library which has some internal code which is doing the following. You provide it to the input depending on the call in a very simple Python native format, what you'd like to do. So if you like to collect the information, you provide the pass just in the string format. You didn't need to care how it will be converted into protocol buffers, how internally different protocol buffer structure are working. You just provide the string, or even you provide a list of string if you like to collect multiple information. And the library is doing the transcoding of the standard, the native Python data into the corresponding data where necessary, into protocol buffers, where necessary, into JSON, where necessary, just serialize the JSON string. So this complexity is removed from you, and you can focus really on your logic. In essence, and like from the user interface, you will see in a few seconds, it just set, it just one class with 4 methods where you providing some arguments in the native Python format, and you're getting the information back. What we have implemented so far, all calls that are existing in the gNMI itself, so capabilities, get, set, subscribe. Subscribe is different encoding because different vendors support different messaging type. We were creating this library over the past year, and like Cisco has a lot of community, DevNet, and so on. It's absolutely brilliant community. However, some other vendors has slightly less presence, and we was focusing predominantly on 2 vendors when we were developing things. This is Arista and the Nokia. And at that stage, when we were developing, the Arista was supporting their subscription, their telemetry in the protocol buffers format. Nokia was yet in the JSON. In the end of last year, they have added support of the protocol buffers as well. But that gave us for us challenge that we was focusing everything that is available on that stage. It was created, tested, works fine. We have also created 2 ways how we could interact with network element in secure channel where the authentication style is based using the credentials, and certificate. In the production network, obviously you like to go with certificate. You would highly likely have a PKI just to avoid any malicious things happening. In the lab, you could play with insecure. Still, the protocol buffers itself doesn't obviously do any encryption, but by the way how the data is encoding, it makes it quite unuseful, quite useless to decrypt if you don't have the appropriate schema into which it was encrypted. So what we are looking further is to add possibility to add a security channel without a certificate. This option exists for like REST APIs for the Python for a while, but for the libraries that are created, like gRPC library we are using in the Python, it is not allowed. There are some links like override where we could like replace certain parts of the certificate with artificial value, which we have implemented with the help of our contributors.
Hello Anton, you have 5 minutes to Q&A.
Yes, sure, thank you. Yeah, and the last thing that we're probably looking into is to have the CLI functionality. We are not very keen to do that because probably there are already tools existing, and our primary goal is to add as a library to the code so that you could easily use it. It gives you simplicity. You just need to install. You don't need to bother how the protocol buffers or anything is working. Just for classes, provide the variables in the native Python format, receive in the native formats. You can integrate it with an ordinary if you like. I know some people like it, well, quite a bit people like it. We have tested it and have a demo online on our YouTube channel, which is showing how it's working. It's working fine, spoiler. You're working directly with the Python dictionaries. You don't need to convert data from any format or to format. You just really focus on your logic. You could directly grab the data received from the output and push it to your netbox or your influx or Prometheus, whatever you are building the logic is. And we're not reinventing the wheel. We are relying on gRPC, a library created originally by the Google, then contributed to the Linux Foundation, which is proven open source and doing its job well. So we have first contributor, so probably a small step, but we were very proud of that someone was also interested in this library and make the test for us for Cisco SXR and added some additional functionality and pointed what were the bugs on Cisco SXR. Now it's proven it's working fine with Cisco SXR as well, which allowed us to improve our logic slightly. So how to work with it? You just go to your CLI where you have Python installed and install it from PAP. You don't need to download it from the GitHub. The latest version all the time updated there. Once you install, you would see the version. Check the release notes because we are adding things or fixing the bugs. So if you have done it previously, and then you might see that some things are not working. We are, if not weekly, but bi-weekly, we are trying to push the updates. Then from the code perspective, it's look, if you're familiar with the Python, quite simple. You just import one class and you create an object. You provide the necessary parameters. The standard for any networking library, you provide the destination, so IP address and the ports, credentials, whether you would like to have in secure mode. If you would like to use secure mode, you provide the pass to the certificate, and you make just, the call. You're getting the response. It's already transcoded in the Python data. You could work with it as a normal dictionary, no further complexity. Same with collection information. Again, you just create the appropriate call, get, you provide their parameters and their encryption from the strings is done to the protocol buffers and back is done by the library. You're getting the response back. So probably scroll, same from the configuration thing, you just need to provide the pass and you need to provide what exactly you configure. Important point that I was asked multiple times, it's not containing any YANC models and it doesn't care about the YANC models. It just works with the gNMI interface. So you need to understand what the YANC models is supported by the device, and you could do it using capability call. And then you just structure your information. You structure the message in terms of the pass and the content, and assuming that you have done it rightly, the information would be applied. If you wouldn't have it rightly, it's not a problem. We are transcoding the messages coming from the gNMI protocol, and you will see in the CLI what exactly is the problem. Like this pass is not existing, or this is K is wrong, or something like that. So you'll have an identification what you need to fix. Yes, working exactly the same. You create the message with the lists, you send, you get the sync again done, and notification either it is working fine or you're getting the error. The final sync with the telemetry is a little bit more complicated. How it is implemented in the gNMI. You need to provide the pass, you provide how often you would like to collect the information, and the format. So it could be either protocol, proto buffers, or JSON. You say that it's streaming telemetry, and then you start receiving this stream. It's implementing the Python like generator. So this is like endless loop where you're getting the information, which again, directly in this loop, you could start like posting it somewhere if you like collecting telemetry and then visualizing this Grafana or anywhere. So it's working pretty quick. If you'd like to learn more about automation, we would be happy to see you in our network automation training. We are running constantly. Thank you very much for your attention. I'm open to your questions. I hope I will done fine on time. If there are any questions.
Thank you, Anton. There aren't any questions just now.